which isn't a great marginal profit, but it is a profit, and it adds to my total profit, right? Nobody would pass up that trade. Okay, so you keep going. Would you hire this worker? Yes, I would, because this worker would produce this extra profit for me. Would I hire this worker? Oh, yes, I would, because they would produce that extra profit. Would I hire this worker? No, because I would lose, right? Marginal revenue equals, in this case, wage equals marginal profit. Okay, let's go here. Watch carefully. What about if the wage rate was here? Would I hire this many workers? The rule says I would hire this amount of workers. In fact, would I operate the factory under these conditions? Would I hire this many workers? Yes or no? Okay, well, let's look at it. Here is the total payment to the workers. Now, I want you to show me where the total profit is. The total grain you get from the output of those workers, where is it? It's below that, right? It's right here. This is the total output you get. Right? So it turns out, actually, you would lose in that case. Now notice, what's interesting about this is that you see that even though it seems to make sense that I would hire, like right here, I would hire people. I hire him, he makes 10 units. I hire him, he makes 20 units. I hire her, she makes 30, 40, 50, 60, 80. You'd think I'd hire so long as every additional person I hired was making more for me. But it turns out, under no circumstances could I ever make a profit that way, as you just saw here. Because I have to compensate for the, the original average that I'm making. Then when I go, it's only in the range of falling average product that I would hire people. Okay? So, that's the relationship between the two. Okay, good. Think about that. Now, you need to be able to draw that. Our next step is this. I want to get the marginal cost function. And it turns out, I'm going to show you how we're going to get that. Oh, by the way, this is the difference. If we're counting in terms of 1, 2, 3, 4, 5, 6, the marginal product is the difference between the 2 and the 1, the product of an additional worker. This one is different because this is the actual change in product, change in labor for infinitesimally small labor. So for example, the function looks like, that we saw here, the function looks like this. Notice the marginal product here, say, of the first worker would be this amount. Everybody? This would be what looks like the marginal product of the first worker. That's one worker. But actually, if you use the slope is not the same as that. The slope is actually steeper. Right? If you look at the change in the slope, it'll be greater. So don't be confused. It just turns out that if you use the change, if the change in the unit is really small, it's not exactly the same marginal product as if you just use 1 unit. But typically, we'll just use 1 unit. Okay? All right. So don't panic too much about it. Our next thing is to get into marginal cost. Explain all this, do that. Cost functions. I'm going to jump. I want to get one simple idea. Fixed costs are the costs of the fixed variables. Variable costs are the costs of the variable inputs. Average variable cost is the average of the variable cost, just like we had average of the product. Average fixed cost, average cost, we'll get to this, I just want to get to this. Marginal cost. What is marginal cost? That's the question. All right, let's think about this. Marginal cost we can define as the change in total cost for a change in output. So, the marginal cost is the cost of an additional unit if the change in output is 1 unit. All right? But use change in output as a broader idea. So notice this. It is this ratio. How much total cost changes given a change in Q? Now, all I'm going to do is say, follow me here. I'm skipping a bit. It's a little bit hard for you, but I want to get to one point. The change in the total cost is the cost of the fixed inputs L, the amount of them, and the variable inputs L, plus the cost of the capital. So the cost of production is the cost of the capital. Now the capital, by the way, it's not the cost of the capital. Well, there's the capital. It's the cost of the capital. Yes, the cost of machines and buildings. Plus the cost of the labor. Everybody, so far so good? Now the next step is we have to figure out what is the cost of each of these units. So it turns out the cost of the labor is the wage rate, right? So this is, if we had this amount of labor, this is the cost per unit of labor. And this is the total capital advanced, and this is the opportunity cost of the capital. So I'm going to give you now, I'm going to choose something over here. Let's suppose we did this. I'm going to get rid of this. Okay. Suppose I have a factory that costs me $1 million to build. Okay, everybody? All right. The opportunity cost, the expected rate of profit, the average rate of profit, or it's the opportunity cost of capital in this case, is 10% per year. Now this is important for reasons we're going to discuss. What is the, what happened here? I don't know what happened there. Whatever it is, it's pretty annoying. Okay, so we're going to have 1 million in K, R, which is average rate of profit if you want, opportunity cost, is 10%. So that's just 10% per year. Okay? Now, I hire 200 workers in a year. I'll make it simple. I hire 100 workers a year and pay each of them $20,000. What is my total cost in the year? All right? Now, this is not a difficult question, although there's an issue here, and it is this. Number one, the variable cost is the wage rate times the amount of labor. Everybody, right? You agree? The total cost of the variable bit is the wage rate times the labor, which in this case is 100 times 20,000, which is what? $2 million. Everybody? I spend $2 million in a year. That's not difficult. I just figure out how many workers I hired and how much it costs to hire each worker. Okay, good. Now here's the slightly more interesting part. If I have $1 million and I use it to build a factory, my $1 million is not, we don't consider $1 million as the fixed cost. Because I could sell the factory and get the $1 million back. That's number one. You might say with depreciation, forget it. When my factory is operating for a year, I mean, I don't have $1 million, but I have $1 million in equipment and $1 million in land. So that's not the fixed thing. You're right, it's fixed, but it's not what I'm going to lose this year. What I lose this year, what an issue of losing this year, is how much my $1 million can take from me. This is very important, right? So my $1 million, when I put up $1 million in capital to buy the factory, my fixed cost this year is the profit I could make on the capital on average in any year. Everybody? So it turns out my fixed cost is, in a year, my My fixed cost in this case is R times K, which is 0.1 times, I'll make this 10 million just to make it simple, okay? This is 10 million times 10 million, which will mean this year I must make $1 million. Or, because I could take the $10 million and I could maybe invest in something else safer.